I am thrilled to have with us Jill Kostel from she's a senior environmental engineer with the Wetlands Initiative, to share with us today a little bit about their research that's going on in Illinois with the tile flows, backhoes, and microbes, constructed wetlands for subsurface drainage treatment. If at any time you have questions, feel free to submit those to me in the chat. And following the presentation, we'll have a chance to do a little Q&A. And so without further ado, I'm going to turn things over to Jill to take it away.
All right. Well, good afternoon, everybody. Thank you to the Iowa Learning Farms, Matt Helmers and Liz, for reaching out and giving me this opportunity to share information on the Wetlands Initiative Smart Wetlands Program. Just a little bit about our organization. The Wetlands Initiative is an Illinois not-for-profit that began in 1995. We design, restore, and create wetlands. We innovate, collaborate, and employ science to improve water quality, habitat for plants and wildlife, and our climate. The majority of our work is restoring wetlands and their associated habitats for biodiversity. However, around 2012, we started working on increasing the implementation of wetlands and other conservation practices by farmers in north central Illinois to kind of address this first benefit of wetlands. Our work with constructed wetlands really ramped up with the development and implementation of the Illinois Nutrient Loss Reduction Strategy. Illinois, similar to Iowa and other Corn Belt states, about 80% of the nitrate loss is from agriculture. And the areas of greatest nitrate loss, shown here in the darker blue in Illinois, correspond very well with the areas with the highest percentage of ag land with subsurface drainage, shown here in the lighter blue. So to achieve our nutrient reduction goals, we need a combination of infill management and tile treatment practices that reduce nitrate loss from the 12+ million acres that have tile drainage in Illinois. I lead our Smart Wetlands program, where we're performing outreach and providing free financial and technical assistance to farmers on the siting, design, and implementation of constructed wetlands for tile treatment. We have a 4-step process in terms of increasing the adoption of this conservation practice, starting with a really proactive engagement and outreach program. Then we work with our interested farmers to perform field assessments for suitability and feasibility. If they're still interested, when we create the engineering design and coordinate with NRCS and the Farm Service Agency if the farmer is interested in a Farm Bill financial assistance program. And then we'll work to manage the construction and the habitat establishment. Now, before I get into all the technical stuff that I do want to acknowledge that we do work within a social ecological system. The human component, as everyone knows here very well, is the most critical component for practice adoption. My colleague, Jean McGuire, is our rural sociologist and outreach specialist. She coordinates our outreach and education efforts, develops our messaging, and really builds those relationships with the farmers, landowner, and their trusted advisors. Mike Rickelson, our wetland tech, and I get involved when there's technical questions and we're ready to go to assessment and design. So this wetland can go by several different names, even with our own organization. We call it a number of different things. We can call it edge of field wetlands, small scale farm-based wetlands, tile zone wetlands, and treatment wetlands. I tend to go with the direct name of tile treatment wetlands. Today, I'm going to be sharing information on the constructed wetlands as defined by the Illinois NRCS Conservation Practice Standard criteria. In addition, there's additional guidance for constructed wetlands treating subsurface drainage. By definition, constructed wetlands are artificial wetland ecosystem with hydrophytic or wetland vegetation for the treatment of water. These are not restored wetlands as defined by NRCS, as restored wetlands have a different purpose for habitat and biodiversity. Treatment wetlands are a mature technology with applications in agricultural, municipal, and industrial settings. On cropland, constructed wetlands are sited to intercept and capture that tile drainage and really designed to remove the nitrate and phosphorus. While very effective, these systems are expensive to implement and can take land out of production. But being a structural practice with a really long life practice, we have to give it a number, so we say 30+ years, they are cost effective. In Illinois, they qualify for EQIP or Conservation Reserve program funding. And lastly, they are wetlands, even if they're being designed for water quality. So they provide ancillary benefits such as flood storage, recreation, pollinator, wildlife habitat, a little bit of flood storage and carbon sequestration. Now, all wetlands are able to remove excess nitrogen and phosphorus through a combination of physical, chemical, and biological processes. Today, I will be focusing on nitrate removal from the tile drainage inflow, which can occur by plant uptake and microbial processes, including immobilization and transformation. Now, the plant uptake is considered temporary storage, as most nitrogen will return to the system when the plant senesces and there's decomposition. The sustainable and permanent means of removing nitrate from the system is through denitrification, where nitrate is transformed into nitrogen gas. This requires three things simultaneously: the microbes, the bioavailable carbon, which is influenced by the plant community, and nitrate. Under low to no oxygen conditions, the heterotrophic bacteria and some fungus are breathing the nitrate in the absence of oxygen and utilizing this organic carbon as electron donor. Now, these processes are, affected by a number of variables, which include the season, soil and water temperature, nitrate loading, the presence or absence of oxygen, and watery temperature. In an agricultural setting, really only the last parameters can be determined by design. So we're really working to establish a favorable environment through design by focusing on the siting, hydraulic retention time, water depth, wetland layout, and vegetation. So wetlands must be positioned in the landscape where they can connect to the source and intercept those high nitrogen loads while minimizing the amount of profitable land taken out of production. So recommendations are capturing and treating tile systems, draining 300 to 200 plus acres. They can go big, just tends to be more land out of production. We want to intercept that tile main right before that outlet at the stream or ditch, or within a grass waterway possibly. We would like an area that has some slope or grade to it. Wet or unprofitable land is kind of the preferred. We don't want to take high value, high productive land out, but we have to make sure these wetlands are not located in a jurisdictional wetland as defined by the Clean Water Act or a wetland under conservation compliance. Prefer not to be in a 100-year floodplain, but as long as they're designed to withstand the flood events and landowner is on board with the operation and maintenance requirements, they can be. They do not have to be located on prior converted or hydric soil land. They can be on upland soils, but we want to make sure we have soils that are capable of holding water as well as serving as a planting medium, which is usually not a problem since these have been farmed for root crops. As part of our taking a really active approach, we're using the agricultural conservation planning framework with our watershed partners to identify potential constructive wetland sites. If you're not familiar, in brief, ACPF leverages high resolution geospatial data for watershed planning, and through a set of automated desktop ArcGIS tools, analyses, a user can really tailor the criteria and adapt existing tools. Our ACPF trained GIS analyst, Jim Monchak, has modified the tools and codes that allow us to site constructed wetlands. We pair this with offsite information such as imagery analysis and field verification to improve our practice suitability and end up producing a nice output map that can guide our outreach efforts. So of the things we control through design are size and depth. Size is key to allow adequate residence time to treat the nutrient loads. We want to make sure microbes have an opportunity to do their job. Given the variable nature and flows of these systems, they're tile driven, the wetland area to watershed ratio is kind of used as our simple indicator of retention time. Research has shown a ratio of 2.5 to 5% is recommended for greater than 50% nitrate removal. We want these to be shallow depth systems, 12 to 18 inches. This provides the maximum soil and water contact and that low to no dissolved oxygen conditions at the sediment water interface. We use the water control structure to maintain normal pool, keep that depth. And this depth really provides conditions for a great emergent marsh plant community. In terms of layout, long and skinny tends to work the best with wetland design. That can be done in a single or multiple cells. We really just want to maximize that hydraulic retention time and flow path. We want the inlet hydraulically distant from the outlet, so we can do that using interior berms, allow the water to flow through. We can create islands and develop deep pockets to help with the flow distribution. You just want to make sure your deep pockets don't lose your graduate student in it. And I will tell you, nature will work to thwart your best design efforts. For example, a family of muskrats got into one of our first wetlands and cut a nice straight line between the inlet and outlet through the berms. So to go back there and do a little repair work. So the NRCS standard, some other little specifics that they highlight is we're daylighting a tile into a shallow pond that's developed either through excavation or embankments with a principal auxiliary spillway. The treatment area is defined as the portion of the site that's 24 inches below the normal pool and 12 inches above that area or that elevation. Areas that are deeper than 24 inches are not counted when computing that ratio. So if you have some deep zones, you want to make sure you're not too deep. The treatment area they recommend is at least 1%. We prefer, once again, based on the research, to be higher. The permanent pool elevation has to be at or below the flow line of your incoming tile that you're intercepting. As you can imagine, this can be challenging if your tile flow line is 3 or 4 feet below the ground. And I can tell you from experience, it is easier and cheaper to upgrade the tile and change its slope than to excavate an extra foot. We want a shallow marsh with at least 50% of the pool having water depth 12 inches or less. And this allows for a lot of microtopography. There is some creativity in how you get to that 12 inches. And you have to allow for the buildup of material from your own plant community, as well as any possible incoming sediment over the life of the practice. These are just some of the examples that I have designed. The main thing is each wetland is tailored to its site based on the land area allocated by the landowner. The preference for straight lines is really nice, so I appreciate that. It makes design a little bit easier. I do want to thank the professional engineers at Christopher B. Burke Engineering who review and stamp my plans, which then can be submitted to NRCS for review and approval for any Farm Bill program assistance in Illinois. And because these are set up for research and monitoring, there's one defined inlet. And we do not have any adjacent surface runoff entering the wetlands through the use of berms and swales. I tried to attempt to eliminate a few variables for the researchers by eliminating that surface water coming in. And through the programs, there's a required buffer around all the wetlands. In this case, all landowners chose pollinator habitat. So I talked about a little bit about the tile flow and the microbes, but honestly, my favorite part are the backhoes. And I should say, technically, we're talking excavators, bulldozers, and pan scrapers, but I cannot rhyme that well, so I went with the easy one. And we partner with the Illinois Land Improvement Contractors Association for construction conservation expos, or work with one of its members for all of our projects. And on occasion, they do allow me into the machine and take a few buckets of soil out, just make sure I'm away from everybody when I do that. So the last critical component is the vegetation. The vegetation slows down the flow, provides that structure, acts as a substrate for the biofilm, which can also contain those denitrifying bacteria. And most importantly, it is our carbon source in this wetland. We want robust marsh species that establish quickly, can reproduce at the design water levels that we're keeping, tolerate the high nitrate concentrations, and be resilient to changing conditions. The first 6 species here are what's recommended through the Illinois standard. We added a few more in our wetlands just as we find these have thrived in the given conditions. Should mention the standard does recommend cattails. I don't recommend putting those in there because they will monoculture, and we really want a diverse community to add some of that resilience. And depending on the site, we rely on natural regeneration and the mystery that will show up once you add waters to the soils, but we also do seeding with supplemental plug planting. I'm going to highlight two of our first projects in Bureau County. Given that we know we have high nitrate loadings coming in, the organic carbon in the wetland is going to be the limiting factor for the microbial community. So how much organic carbon is needed and how long does it take to reach that optimal level for removal? Is there a warm-up period as the wetland microbial and plant communities are getting established? And essentially, how can we provide the best conditions via cost-effective design? To answer these questions, among others, was the research work of now Dr. Masa Azamir under the advisement of Dr. Carl Rockney at the University of Illinois at Chicago. We funded this work through a multiple year grant from the Illinois Nutrient Research and Education Council. And I'm just going to touch on two findings, the nitrate and the organic matter of all the work that Masa did. So two wetlands under comparison, much to the chagrin to researchers, were not exactly the same, but these are constructed wetlands on working farms after all. CW1 was built in late summer 2015 with non-wetland soils as the plant base. The wetland treatment area was 0.7, which turned out to be around 1.8% of the contributing surface drainage area. We did not have a tile map for this one, so we used 3 different methods to estimate the tile drainage, and I think we still underestimated it. CW2 was built in the following summer with wetland or hydric soils as its growth media, and it is operated via a tile pumping station, has a wetland area of 0.8 acres, so that's around 3.6% of the contributing subsurface drainage area. We had a tile map for this one, so that one was, make sure we can get the area perfect on that one. Both wetlands were seeded and planted with the same emergent vegetation. But the main differences between the two were the soil type we started with, as well as that ratio. I should also add the operation was slightly different. In 2015, that water was entering as soon as we were done post-construction. And CW2, we were able to start the flow a little bit later in 2017 as that plant community was starting to get established. Diving into some results, we're going to use 2018 as an example year. And these graphs show the inlet concentrations and the outlet concentrations for nitrate. For CW1, we do not see a big difference between the inlet concentration shown here in blue and the outlet concentration shown here in green, except in the summer where we see the highest rates of denitrification. In comparison, we see a big difference in CW2 between the inlet in the blue and the outlet concentrations as shown here in green. The outlet concentration was usually around or less than 0.5 milligrams per liter. As I mentioned, there are a number of factors can affect removal. So we tend to use multivariate statistics to kind of help explain this. We do a direct comparison of the average monthly removal efficiencies. We see much higher removals in the warmer months when denitrification rates are the highest. CW2, the second wetland shown here in the green bars, had a much higher and consistent removal during the growing season. After a slow start, CW1 started performing better, but it dropped off the following year, and especially in the late months of 2017, and this was due to a drying event that occurred. There's really no rain coming in for a month or two. So it took a while for the system to rebound in 2018, and then 2019, we kind of got back to that 27 level of operation. I prefer to look at mass load removal and considers both the concentration and flow. Here are the cumulative annual loads in and out of the two wetlands over the study period. And what we see is about 7,000 pounds was removed over the years in CW1 in comparison to about 25,000 pounds removed in CW2. I must mention these were both really high flow systems, especially during storm events. But CW1 was really hydraulically overloaded compared to CW2. And the statistics kind of confirmed with CW1 that the flow was really strongly negatively correlated with CW1. I do want to mention our friends over at the Nature Conservancy Illinois have been researching small constructed wetlands for over the last 12 years. And they just published a paper that's out in the journal Environmental Quality. And they also saw similar mass nitrate removal between 28 and 52%. Now we're looking at the organic matter in our system. Sediment samples were taken at 2 depths at 3 zones in each of the wetlands. Upper zone was closest to the inlet, the middle of the wetland, and then the lower zone near the outlet of each of the wetlands. Right here, I am showing the findings for the superficial sediments from 0 to 2 centimeters. And we can see that the overall average in organic matter was building over the study period in CW1. But we do see that, it took a hit actually below its original levels after that drying period, where we ended up oxidizing out some of the carbon that we had accumulated. And then it rapidly regained some of that carbon content. CW2 just kind of started at a high percentage, about 6%, and then increased to 8%. Its increase was less than the increase rate of CW1, but started out that high level. But really, it's really about the bioavailable carbon, what is available for the bacteria to utilize as their energy source. And so looking at the labile or bioavailable fraction of the organic matter, we can see that initially in CW1, we started out around 2% and then slowly built up to around 4% over the study period. In comparison, CW1 started out at 4% and just kind of increased to a little over 6% on average. And as we would expect, there was a really strong positive correlation between both sediment organic matter and the labile fraction and nitrate removal. But even though CW1 was the poorer performing of the 2 wetlands, it still was doing great removal in terms of how many pounds per acre treated. I put everything, apologize to the scientists out there. We're not working in kilograms and hectares, but pounds and acres, because this is how we kind of show the information to our farmers. So our major takeaways here are that if whenever possible, we really would like a minimum of 5% organic matter and 3% labile organic matter to really get those high rates of nitrate removal right away. If possible, using that hydric soil would be great to bump up those initial concentrations, but it also has to do with how the ground was farmed and what the organic matter in the soil, that initial soil is. If all possible, we prefer to establish the vegetation prior to having all that drainage coming in. It results in a better performance due to that first maybe year of vegetation getting established and providing the organic carbon into the sediments, and also prevents that channelization of flow that can lead to short circuiting of the system. We want to manage the water levels to prevent fully drying out the sediment whenever possible, because drying out leads to the oxidation of that material, organic matter that we're really trying to build up. Similar to the research that is out there, we're finding wetland areas that are closer to 3 to 4% of the drainage area would help with the hydraulic residence time and increase nitrate removal. So overall, they work. I think we've shown that what we know in terms of already about these wetlands and their ability to remove nutrients. In this case, with a conservative estimate, we're moving that 23 to 46 pounds per acre drainage captured per year. So making it really a cost-effective practice over the performance life of the wetland. And a last note, in response to climate impacts and the increase in subsurface drainage going into the ground, we know wetlands can provide community resilience. Constructed wetlands may not provide all the benefits to the same extent as a natural restored wetland. However, in areas where wetlands have been completely lost, we can facilitate natural processes through an engineer ecosystem approach. And constructed wetlands are really resilient ecosystems. They can recover from disturbance, whether that's flooding or drought. They will come back each year. And it's really a sustainable nutrient removal process. And on that note, I would just like to acknowledge and thank our partners and funders, otherwise this work would not be able to done. And our outreach has really extended thanks to the partners at the Illinois Sustainable Ag Partnership, where we're cultivating a culture of conservation and innovation that includes tile treatment practices as part of a whole systems approach to nutrient loss, while minimizing risk and increasing profits for the farmer. And at this point, I am happy to field any questions.
All right, thanks, Jill. And if you want to go one more slide while folks are getting their questions
Absolutely.
in as well, and then we can go back to your contact information. So yeah, folks, if you have questions, feel free to submit those to me in the chat. A couple questions have come in. Someone's curious, here in Iowa, especially the Des Moines Loeb area, we have flat tile designs and flat topography that makes outletting tile difficult in many locations. So how much extra is it to cost in terms of design and building when there's a pumping station that's used?
Well, I would not suggest using tile pumping stations if all possible. It's just, we try to make these low maintenance, gravity fed systems whenever possible. We did this as an experiment in a way. The soil is kind of required just to make it easier for building. We would not be building in the wet, even in August. But I think, if you had a tiling pumping station, it actually is pretty easy because the water's already at the surface and the tile's outletting, pretty much at the surface level. So that's great. And therefore you wouldn't have to excavate, maybe more making embankments around it than not. But I would say if you don't have a tiling pumping station, probably best not to use it. Like I said, we want these to be gravity fed, low maintenance, almost a leave it and forget it practice. But don't forget it, go out there and enjoy it while you can.
So while you were presenting, Jean shared your TNC research paper. So there's a link to that for folks in the chat. So you can check out that paper on constructed wetlands. So question is, what do you think the costs look like for these constructed wetlands, the ballpark range of the different projects you've built out?
Yeah, they can be anywhere. Once again, it's all depending on the amount of excavation. Excavation is the expense. So they can range anywhere between $30,000 and $80,000. And so we try to limit the excavation as much as possible.
So I'm going to address this question, but also then throw it as to Illinois. Someone's curious on how many of these constructed wetlands there are in Iowa. So in Iowa, we're typically looking at something like the Conservation Reserve Enhancement Program, and there are now at least 100 of those. So how many of your constructed wetlands or similar style have you completed in Illinois?
We've done about 5. We've done 5 with the 6th one coming on the way. And I believe TNC has 12 or more constructed wetlands treating tile. And yeah, these are different than the Iowa CREP wetlands. Iowa CREP wetlands are a little bit more structural, and you're also taking in a much larger drainage area. So these are very farm specific and farm based, trying to eliminate or reduce that amount of land taking out of production, both systems to work.
And you addressed that there's a social aspect to this. So what do you think are the main barriers to wetland implementation by producers?
Oh gosh, Jean's on chat here, so she can answer this, but I've been paying attention to what she's been saying. I think a lot of it is just they hear the word wetland and they don't, they're thinking, oh, we want to restore all my wetland back to wetland. And it's like, no, we're just interested in treating your tile with a small farm-based wetland. And I think that kind of gets over it. But a lot of it is just awareness of the practice, understanding the practice, and understanding how it could fit within their farm operation. And then, showing them that that works too. So the data is really important.
And do you require that the landowners get an easement when they do these projects?
No, we do not require, other than what's required on the EQIP and CRP. So under both of those programs, it's a 15-year practice. It's a continuous practice. It's CP 39 and CRP. And so they can keep re-signing and re-enrolling it after their contract period. Though we don't say they're permanent, but then again, we're often removing 4,000 cubic yards of material and making a hole. So they would have to fill it back in. And I think that's why we really kind of emphasize to our farmers, like, make sure this is where you want it. because it's probably going to be here, but it's not a permanent easement, and under the Army Corps 404 permit, it is not a jurisdictional wetland at this time.
And have any of your producers completed a project without going through the Farm Bill programs?
We are working on one now, but all the rest, 3 were CRP, 1 was EQUIP, and then 1 was on the campus at Illinois Central College, East Peoria campus. And so that was funded in partnership with the college.
And what's about the average size of pool and buffer that you're aiming for on these projects?
Once again, it depends on the drainage area, but all of our projects have been around 0.8 to 1.2 acres in treatment area. And then depending on the program, how much buffer is required. So we're talking 5 acres to 10 acres, maybe out of production. Once again, if the landowner gives us an area to work in, we work with them in adjusting those buffer lines such that they can, maximize their farmland.
How long does the installation process typically take from start to finish? So from design to excavation to it's operational.
That's a great question. About a year if all things line up perfectly. We have to, if we're working with farm service agents or NRCS, we got to work on batching periods and sign up periods often, and then getting through the design process. There is a lot of communication back and forth with the landowner. We love doing construction of these during the summer. The water table is down, makes it much easier. Construction can take, depends if you have 15 pieces of equipment out there as a great, like an expo, or you have a contractor out there. It can take a week to 3 weeks in construction, once again, depending on weather and what else the contractor has going on. So, and then next year is when we do a temporary cover through the fall, and then the next year it's ready to go with the native vegetation going in it. So it can take, we try to speed up the process as much as we can. Sometimes there's some roadblocks in the way and we just work around it. But as we're doing the design, we have that commitment through the farmer. We're going through the permit process and the design process very quickly.
So this one is a great question. Saturated buffers, oxbows, and constructed wetlands all treat tile outlets. What's better? Which practice?
You're asking someone who works for the Wetlands Initiative about saturated buffers? No, I really think it depends on the site. And I love the idea of using oxbows. I think that's a great kind of a tile treatment restored kind of activity. I think in terms of design, a constructed wetland can give you the it can capture those higher flows. Nothing's really bypassing the wetland. You're still going to get some removal, even if it's kind of going through there very quickly. It provides all those other ancillary benefits as well. So I'm always thinking constructed wetlands. I just haven't done an oxbow yet, but I know in Iowa there's some oxbows, and I think Missouri there's some oxbows going in, which I think is a great another use for tile treatment practices.
Actually, there's another question that came in, and maybe this is tied to it. Jean also shared with us some of your research results. There's a link there in the chat if folks are curious to look up some of the demonstration monitoring results directly there through your Nutrient Research and Education Center. So what are your monitoring plans going forward? So you mentioned that grant, and do you have plans to monitor the nutrient removal performance of all or some of these systems over the long term?
Yeah, that's a great question. We want to be like TNC. We want long-term databases. So we have monitoring equipment set up at 4 of these wetlands. Now we're just looking for a new graduate student. I think we've shown they're just not going to monitor the nutrients coming in and out. That's been shown. Obviously, as a graduate student and working on a thesis or a dissertation, we want to get an exciting angle for them to look at and do that work for us. But yes, we would like to keep on monitoring. We have the funding to do that. The one at Illinois Central College, that data's come through. That's funded through the Illinois Corn Growers Association and then analyzed off-site, but we get that data. So that one I hope continues for 3, 4, 5, 10, 12, 20 years. That'd be great. Just depends on funds and students.
There you go. So someone was being very attentive because I saw that on your list of partners, you have a brewery. What's the backstory there?
Very good. Yes, we had a brewery involved. I got totally totally spaced on the name right here, who our brewery is. I'm going to cheat and go back here.
Yeah, feel free to go back.
I'm going to cheat and go back here. New Belgium. Yeah, Flat Tire. Yeah, they had a program where they had a clean water aspect, and just by connections, we knew they had a small funding grant pool, and so we had funding for a couple of years. We have a very great grants manager who finds these sources of funding, so it's great. But yeah, we did not get any free beer out of it. The local breweries were looking to work with you too. It's all about clean water.
So tied to the monitoring question, do you have plans to evaluate the hydraulic performance, such as resident time distributions, under your different system designs?
Yes, and so we have done tracer studies and done, that part of the hydraulic modeling retention time. It never fails when we're out there to do a tracer study, we get a huge rain event. And so often we're capturing those high water events or those high flow events, not so much the normal resonance time. So, but yes, we do want to, if possible, keep doing those type of studies and experiments just so we get a really good sense of the retention time under different flow conditions. It's much easier if you were a wastewater treatment plant wetland doing that polishing, because you get the same flow pretty much 24/7. But this is agriculture, things are very flashy. And so we try to capture the normal flow, low flow, as well as the high flow events if we can.
So a couple more questions. Thank you for putting up that next one. If folks want to join us next week, we're talking 2-stage ditches. So kind of keeping on treating floodplain waters. So someone's curious and noted that this is a little technical, but doesn't the CP39 require a 2-to-1 buffer to wetland ratio? Has the large buffer been harder to sell to the landowner because that requires more land taken out of production, or is the potential habitat of the large buffer motivating to them?
I think with the landowners that we have worked with, it's actually motivating. Sometimes you can go up to 4-to-1, and it's kind of surprising. They kind of want to go to that 4-to-1 sometimes, because part of it is just making it easier to farm around too. So, and under equip, you're based on the slope. So if you have a lot of grade, you're going to have to essentially design it like a filter strip. And so I think that's part of the package that's attractive. We do try to work with them, if they want to do some farm passes around it, or they have certain edges and corners they like to keep, we work with them. But yeah, everyone, they can choose between grasses or a mix, and every one of them has been really interested in pollinator habitat.
Does the DNR and the Corps of Engineers need to permit your wetlands? And we'll answer that one first.
Yes. The Army Corps does. We do apply for a 404 permit, as well as, and they come back with a nice letter saying it's not jurisdictional. It falls under a nationwide permit, which actually gives the landowner the right to fill it back in within, I think, 3 years of the end of their last contract. And we do work with DNR. We have to go through the EcoCat, make sure there's no species of concern, threatened and endangered, floodplain, and to make sure we're not with our berms causing any offsite impacts. And so yes, we get permits from both agencies.
Can the farmers use these wetlands that they're putting in to sell mitigation credits? I'm not familiar with any programs that exist like that, but are you aware of any?
I think that comes under double dipping in the in the world of mitigation banking. You cannot use federal dollars for mitigation, but if it's not a full cost share, it's not 100% covered by federal dollars, then you take the 80% that you're putting in, you potentially could sell those as mitigation credits, but that has not been done as I think. Usually we try to keep farm bill programs one way and mitigation the other way.
I think maybe you addressed this, but if you could just reiterate a little bit about your ratio of so many acres of cropland to so many acres of wetland needed to actually effectively remove nitrates.
Yeah, so I would say the standard requires at least 1% of the drainage area. Hopefully it's just tile drainage, but it has to include surface drainage if you have that coming into the wetland for the treatment area. We recommend around 2.5%, if possible 5%, but once again, that's more land taken out of production, but that 2.5% seems to be kind of like the Goldilocks. So, we're not too big, we're not too small, we're just right. And back to the mitigation question, I should add, if a farmer was interested in building a wetland for mitigation and not receiving farm bill dollars, that would be kind of interesting to see. Because you're really, for mitigation though, you're designing for restored wetland that's been taken out of production or for development. So I'm not sure a constructed wetland would, provide the criteria that are needed in a mitigation bank.
So you can elaborate a little bit about Illinois, but here in Iowa, if folks are interested in putting in a wetland, they can contact their local watershed groups or their NRCS. Similar experience for Illinois landowners?
Yep, exactly. Or they just reach us directly or one of our partners somehow, and they kind of get shuttled to us. We have a great relationship in our focus counties with NRCS and our soil and water conservation districts. So working with them, we've done ACPF modeling in some of those areas to help guide that, because they're interested and landowners are interested. They, is my farm suitable for one of these practices? And so we kind of use that as our guiding of potential opportunity areas. So yep, absolutely reach out to your local office.
Yeah, so if you are from here in Iowa, this is a good point, and you're interested in a wetland or an oxbow, feel free to send me your contact information in the chat. I can connect you with folks here in Iowa through our Iowa Department of Ag and Land Stewardship. They have some initiatives to help folks get those on the ground as well. Trying to make sure I catch everything. So someone's curious on how you're able to design NRCS practices. Do you have an agreement with them that you are able to do that and have them sign off?
No, it's just long as you have a professional engineer stamp it and design it with a statement saying it's designed to the best of their knowledge, the practice standards. But NRCS, the engineer who's reviewing it does have to review it. We have a little back and forth going back on that, and then they have to approve it for funding. So it's a collaboration, but we try to go out there and do the design, not necessarily as part of our technical assistance aspect here. So we do not have a specific agreement in Illinois. But a professional engineer does need to be able to stamp that plan for a constructed wetland.
So we did, we draw folks from Iowa, Illinois, and in this case, Minnesota. Someone's noting that most tile outlets go into county ditches. Mm-hmm. Wouldn't it be practical to design ditches to be more effective than they currently are? So just kind of your analysis on that, and you can punt if you wish.
No, I'm not going to punt to next week. Jennifer, Dr. Tank can talk about this a little bit. But yes, I think you see that in Iowa where you have drainage districts, which are managed. You can have an opportunity to get collaboration with the farmers to build a great wetland. I know in Minnesota, they're looking at the roadside ditches as well as a way of, doing something similar that Dr. Tank will be presenting on the two-stage ditch. But yeah, it would be great to take advantage of systems that are already in place and less land out of production whenever possible. We like to think that treatment wetlands can go everywhere, but they can't, right? There's other practices that are often you have to kind of look at to see what is best for the farmer.
Let's see. So okay, someone chimed in here. For private engineers working with the NRCS in Iowa, it's the same as Jill described. We will accept any non-NRCS designed plans with an Iowa professional engineer stamp that meets NRCS standards.
Yep.
So clarification on that.
Mm-hmm.
So yeah, I think, again, if you have questions about, and you're looking for maybe possibly putting in wetland or oxbow saturated buffer bioreactor here in Iowa, please send me your email in the chat and I will connect you with folks in our Iowa Department of Ag and Land Stewardship. Jill, if you want to go back and put your contact information back up, so if folks are from Illinois and they want to reach out to you directly, they can do so.
And similar with, if they're interested in saturated bioreactor, feel free to reach out and we'll figure out what county you're in and work with the partners that we have as well as your local soil and water and NRCS.
Excellent. Well, thank you all for tuning in today and for your excellent questions. It's been a real pleasure to get to chat with Jill today. We hope you can join us again next week, again, as we learn about two-stage ditches and continue our weekly conservation webinar series. Have a great afternoon, everyone.